Okay, let's continue. We look at distance between 2 points in three-dimensional space. So consider 2 points P equals x1, y1, z1 and Q equals x2, y2, z2 in three-dimensional space. So we can ask, what is the distance between the points? So we can draw a picture for one case. So suppose this is one of the points P, x1, y1, z1. So it's hard to visualize them in three-dimensional space. Okay, so this is one point P equals x1, y1, z1, and this is another point Q equals x2, y2, z2. So we are interested in the distance between these 2 points. So what we can do is, so this is picture for one case. We can draw okay. Instead I'll start the picture like this. It will be clearer. So we can draw a cuboid. We can draw a box basically. Such that one of the ends is this point Q and the other end is this point x1, y1, z1. So we have these 2 points and we can draw a cuboid such that these 2 points are the opposite vertices of this cuboid. And so what is the distance between these 2 points? That is the question. So note that the sizes of the side lengths of this cuboid are known. The side lengths are known. For example, in this picture, this side length is x2 minus x1, right? So suppose the coordinate axes are also aligned like this. These are the coordinate axes, which I am not drawing, but yeah. So this distance is x2 minus x1 and this distance is y2 minus y1 and this distance is z2 minus z1. If we think about it, by the definition of the coordinates, the side lengths of this box are x2 minus x1, y2 minus y1 and z2 minus z1. Okay, so this is picked for one configuration. So in this configuration, what is the distance? Well, we can apply Pythagoras theorem twice. So consider this length, which we can call L. Then the distance between P and Q is square root of, so square root of L square plus Z2 minus Z1 square. So this is by using Pythagoras theorem on this triangle. This is a right angle triangle and we are using Pythagoras theorem on this right angle triangle. So this is by Pythagoras theorem on this blue right angle triangle. Okay, so square root of L square plus Z2 minus Z1 square. But again, by Pythagoras theorem on, for example, this red triangle, this is also a right angle triangle. L square is just x2 minus x1 square plus y2 minus y1 square. So this is by Pythagoras theorem on this red right angle triangle. So we have basically used Pythagoras theorem twice. The distance, so distance between P and Q is square root of L square plus Z2 minus Z1 square. And L square is further x2 minus x1 square plus y2 minus y1 square. So by using Pythagoras theorem twice, we get that distance between P and Q, these two points in three-dimensional spaces, x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. So as with the previous case, note that the result is true for other configurations. So in this picture, we conveniently took x2 to be greater than x1, y2 to be greater than y1, and z2 to be greater than z1. So pick for one case. This is in the pick x2 is greater than x1, y2 is greater than y1, z2 is greater than z1. So for convenience, we took it like this, and we found the distance is square root of x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. We can see that the result is still true for other configurations. So because end of the day, you are squaring the difference in the coordinates, and whether it's x2 minus x1 or x1 minus x2, it doesn't really matter. So okay, so that's all for this part. See you in the next part.